Okay, we are back with part 2 of section 6.8, and we're going to start talking about logarithmic regression. Logarithmic regression is used to model situations where growth or decay accelerates rapidly at first and then slows over time. We use the command lnreg on a graphing utility to fit a logarithmic function to a set of data points. This returns an equation of the form y equals a plus b natural log of x. This is very similar to what we did with the exponential regression. For the logarithmic regression, note that all the x values have to be positive or non-negative, so not negative. And when b is greater than 0, the model is increasing, and when it's less than 0, the model is decreasing. So how to use a TI-84 to find the equation. We know how to put in data. We know how to do a scatter plot. So let's look down at number 3. To find the equation, you hit stat, you arrow right to calc, and you go down to lnreg. lnreg, so natural log regression. So log regression. It's going to give you the equation in the form y equals a plus b natural log of x. So if we were to use Desmos instead, we know how to put the data in the table. But in another box, you'll type in y1 or the number matching the table that you created, because if you put in more than one table, you can have table 1, table 2, table 3, etc. So y1 tilde a plus b ln x1. And then replace the a and the b like you would in the other scenario with the other calculator. Alright, so looking at this example, it says, due to advances in medicine and higher standards of living, life expectancy has been increasing in most developed countries since the beginning of the 20th century. The table shows the average life expectancies in years of Americans from 1900 to 2010. So notice we have 2 rows of years, so this is all the X's. And then we have 2 rows of life expectancy, so that's all the Y's. Alright, so we're going to let X represent time in decades, starting with X equals 1 for the year. In 1900, X equals 2 for the year 1910, and so on. Okay, so 1900 is 1. 1910 is 2, so 1920, so we're going decades, counting decades, so it would be 3. We want to let Y represent the corresponding life expectancy. We're going to use logarithmic regression to fit a model to these data. So go back up here, and let me just kind of show you how you're going to do this. For 1900, you put in 1. For 1910, you put in 2. 1923, 1934, 1940 you put in 5, 1950 you put in 6, 1960 you'll put in 7, 1970 you'll put in 8, 1980 you put in 9, 10 for 90, 11 for 2000, and 12 for 2010. And then the life expectancies would be the regular numbers. So pause the video. Enter your data into either the TI-84 calculator or your Desmos calculator. When you're ready to find the linear regression equation with me, unpause the video and we will do that. Okay, so I'm going to start with the TI-84 calculator. Alright, so I think I put my data into L3 and L4. Let me just double check. 47.3 was the first one. Yeah, so L3 and L4 is where I put my data. That's where my data is. So to find the logarithm regression, we go to stat, arrow right to calc, and choose lnreg. So mine is 0 on this calculator, but yours may be a different. Okay, don't press don't press linreg. Hit lnreg. Let me just clear that and do it one more time so that I didn't have anything else on the screen. So you may have prompts where it asks for, X list and Y list. You're going to put in which list you put them in, like L1 and L2. If you have a type of calculator like this, you'll just hit L1, comma, L2. Oh, actually, no, I shouldn't put L1 and L2, should I? I told you guys it was an L3 and L4. So adjust if necessary. If you did put them in L1 and L2, then that's what goes there. Enter, and there we go. We have A is 42.5272. So let me just go ahead and write that down. Y equals 42.5272 plus 13.8575 ln of x, like that. Now let's double check with Desmos. Alright, so let me find the data. Let's see. Okay, this is in L3 for me. So let me erase what was on here. Alright. Alright, so I've got it in X3 and Y3. There we go. So there's the data, but I want to hit the plus sign to so that we can see it. Hopefully I put everything in correct. So I want to add an expression, and I'm going to type in Y. I'm going to put Y3 because that's where my data is. Y3 tilde A plus B natural log. So go to functions, miscellaneous, choose natural log of x3. And don't forget to click log mode. And you still get the same answer, 42.5272 plus 13.8575. It's the same thing we got here. So y equals 42.5272 plus 13.8575 natural log of x. So it says use the model to predict the average American life expectancy for 2030. Okay, so going back to the table, 2010 is 12. That means that 2020 would be 13, and that means that 2030 would be 14. So we're going to sub in 14 for the x. So we're going to do y equals 42.5272 plus 13.8575 natural log of, and what did we say that was? I've already forgotten. 14. So you're going to put in 14. Alright, so I can add another expression, and I can type it in like this. 42.5272 plus 13.8575 natural log of 4. Did we say 14? I believe we did. And we get 79.097. So 79.097. If we went, another thing we could do instead, so add another expression, I could type in x equals 14 and then see where it intersects. And it does intersect at the same place, 79.098. They round up to 8. And I got, oh, you know what? 0979 would have been, I wrote this wrong. This should have been 8. Yeah. So you can do it algebraically, or you can use the graph to help you. If they had given you, instead of an x and they'd given you a y instead, you could put in y equals into the equation, substitute for the y, or you could put y equals into Desmos and see where it intersects to solve. All right, so your turn to try it. So here is data for sales of a video game released in the year 2000. Took off at first, but then steadily slowed as time moved on. The table shows the number of games sold in thousands from the years from 2000 to 2010. And we're going to, if you look down at A, it says let X represent time in years, starting with X equals 1 for 2000. So that means this would be 1, 2001 would be 2, 2002 would be 3, so on and so forth. So go ahead and fill those in. We are going to find the logarithmic regression to fit the model to these data. And then if the games were to sell at this rate, how many games would sell in 2015? So pause the video and then come back when you are ready with the data in your calculator. And you can go ahead and try to work both A and B yourself, and then come back and we can go over all of it. Okay, so hopefully you put this in your calculator and you found the regression equation and you were able to estimate the number of games they'd sell in 2015. If you were using your TI-84, you go to Stats, Edit, put your data in. I've got my data in L5 and L6. Then you would go to Stat, Calc, choose LNREG, and then fill in the prompts, or in this case, my data is in L5, L6. And it looks like my equation is y equals 141.9124. Let me move this down a little bit. So for part A, y equals 141.9124. Just write into the fourth decimal place, plus b, which is 10.4537. Natural log of x. Okay, so now let's look at Desmos. So I've got my data in table 4. So I hit that little plus sign on the bottom to help it zoom in to where it needs so that you can see it. So we'll do y4 tilde a plus b natural log x4. Click log mode, okay, and there you can see it's a nice fit. We get 141.912 plus 10.4537 natural log of x, which is what we got here. We just went out one further using our TI-84, but basically you get the same thing. So now let's look for part B. If games continue to sell at this rate, how many games will sell in 2015? Round to the nearest thousandths. So 2015, if 2010 is 11, then 2015 is 16. All right, so that means that I am going to rewrite this equation. 141 point, I'm just going to do the 912 like we had on Desmos, because this is where I'm going to do the calculation. And where we have x, we're going to substitute in 16. Okay, so going to Desmos. Here's the equation and its graph. So what we can do is we can add another expression and type in 141.912 plus 10.4537 natural log of, we said 16. And we get 170.895. 170.895. It says round to the nearest thousand. So this is in, if you remember, this is in thousands. So this is the nearest thousands would be right there. That's 170.895 thousand. So the 8 tells the 0 to become a 171, so 171,000. Okay, now let's go back to Desmos and look at the graph and use the graph to solve it instead of algebraically. I can type in x equals 16 and scroll over to the intersection, and you can see that you get 171 that way as well. Okay. Alright, so that looks like that's it for this section. That's it for chapter 6 altogether. So if you have questions, definitely let me know.